You know about the moon. Everyone does. One moon has always been there, will always be there. Earth has a second one. It arrived in 2023. It is about 10 meters across. It has been quietly orbiting our planet alongside the moon, and nobody mentioned it to you. Earth has a second moon. I'm Hassan. This is real. It is happening right now. And the story of how Earth temporarily captures these objects tells us something important about how dynamic our cosmic neighborhood actually is. What it actually is. The object is called 2023 FW13. It is an asteroid, a small rocky body about 10 to 15 meters in diameter. It orbits the Sun, not Earth. But its orbit is so similar to Earth's that it stays near us for an extraordinarily long time. Scientists call objects like this quasi-satellites. They are not true moons in the classical sense. They are not gravitationally bound to Earth in the way our moon is. But from Earth's perspective, they appear to orbit us in a slow, looping path, staying within about 100 times the moon's distance for decades or centuries at a time, before drifting away. 2023 FW13 has been near Earth since roughly 100 BC and will remain in our vicinity until approximately 3700 AD. It has been accompanying us for over 2,000 years without anyone knowing it was there. It is not the first. Earth has had temporary companions before. In 2006, an asteroid called 2006 RH120 was captured into a temporary orbit around Earth for about a year before escaping. Astronomers believe Earth regularly captures small asteroids into brief temporary orbits. We just rarely detect them. How capture happens? Temporary capture happens when a small asteroid drifts into a region of space where Earth's and the Sun's gravity interact in a specific way. There are points in space around every planet, called Lagrange points, where gravitational forces balance in a way that allows objects to sit in stable or semi-stable positions relative to the planet. Near these zones, a passing asteroid can get caught in a gravitational dance, not quite orbiting Earth, not quite escaping, but locked in a temporary partnership. The partnership ends when small gravitational nudges from the Moon or from other planets gradually change the asteroid's path enough that it drifts out of the capture zone. For small objects like 2023 FW13, this can take years, decades, or in rare cases, centuries. The reason we rarely know about these companions is size. Why this matters? Quasi-satellites are scientifically interesting for a practical reason. They are the easiest asteroids in the solar system to visit with a spacecraft. Because they orbit near Earth, reaching them requires far less fuel than a mission to the asteroid belt between Mars and Jupiter. A quasi-satellite is essentially an asteroid that has come to us. This makes them attractive targets for sample return missions, sending a spacecraft to collect material and bring it back. The composition of these objects tells us about the early solar system. Small asteroids are often pristine, unchanged, since the solar system formed 4.5 billion years ago. The material in them is the same material that built Earth, Mars, Venus, and every other rocky body. Understanding what they are made of helps us understand where we came from. There is also a long-term resource angle. A 10-meter metallic asteroid can contain more refined metal than a medium-sized mine. As space mining becomes technically feasible in the coming decades, quasi-satellites, close, accessible, metal-rich, are among the most attractive targets. 2023 FW13 will be with us until the year 3700, long after everyone alive today is gone. Long after civilizations that do not yet exist have risen and fallen. It arrived before the Roman Empire reached its height. It will leave after whatever comes next. Our moon is a permanent companion, shaped our tides, our seasons, possibly life itself. 2023 FW13 is a temporary guest, a small rock that happened to be passing through the right part of space at the right time, caught by our gravity for a few thousand years, completely invisible to the naked eye, going about its own quiet orbit alongside us. The sky is more populated than it looks, and we are getting better every year at finding out who else is up there.